Hello, welcome. I'm Claudia Rizzini, the Executive Director of the Radcliffe Fellowship Program at Harvard University. I'm excited to introduce today's talk by Radcliffe alumni professor Susan Murthy. Susan has had a long career as a researcher and teacher of mathematics, specializing in statistics. It would only be inaccurate to describe her as a mathematician wizard, because, in her own words, she likes maths because it's something you can never gain complete mastery of. Susan's research interest concerns the development of personalized mobile apps with the goal of helping individuals manage chronic health disorders. Susan leads the Statistical Reinforcement Learning Lab at Harvard. Her laboratory develops computational algorithms and statistical methods at the intersection of computer science, mathematics, and statistics. She developed a new type of clinical trial called the micro-randomized trial, which is used in developing high-quality mobile health apps. In these trials, an algorithm, that is a software code, it's used to learn and personalize when to deliver different kinds of behavioral interventions to help each individual achieve their health goals. One example of behavioral intervention is a tip about what the person can do at that very moment to be more physically active. These algorithms use information on an individual, such as whether the person is at work or at home, or whether the person has slept well that night or not so much, to learn which behavioral intervention is most useful to them at that time. The micro-randomized trial is now in widespread use across the mobile health field. Susan Lab welcomes undergraduate researchers, and she has described working with them as among the favorite moments of her job. She enjoys not only helping people with her work, but introducing new researchers to how useful math and statistics can be in our society. I am delighted to give the floor to Professor Susan Murthy. Thank you.
Thanks so much. It's a pleasure to be here. It's particularly a pleasure because the first time I was a Radcliffe Fellow was 2019 to 2020. And right before my talk, everything closed up because of COVID. As Claudia mentioned, we work on a whole variety of digital interventions. I put some of the icons here, a selection of them. It's across different areas, mainly though for individuals that are struggling with some sort of chronic problem. Today I'll use Heart Steps, which is on your far right, in the middle, to discuss the ideas. So I want to first say, this is, you have to, thank you to all my collaborators. This is a field, it's a big data science field in terms of you need many, many people to do anything, to make any progress at all. And this slide has pictures of human-computer interaction scientists, computer scientists, a dental surgeon, behavioral scientists, other computer scientists, students in statistics, and software developers are on this slide. So what I want to do today with you is I want to discuss what these micro-randomized trials are and how they're part of a scientific progress whereby one can learn how to personalize an app, a health app to individuals. That involves, these micro-randomized trials can involve different types of artificial intelligence algorithms, one of which is called reinforcement learning, and we'll talk about that in the middle. And then, as all of you know, there's been a number of problems in AI where the algorithm makes a profound, it appears as if the algorithm is very sure, and in fact, the algorithm is making a mistake, and there's all kinds of unintended consequences. So at the very end, you'll see a little bit of a discussion of how one can look at the output of these algorithms and question that output. So let's think of a situation for Jay. Jay was just diagnosed with high blood pressure, stage 1 hypertension. And Jay knows that if he increases his physical activity, he manages his stress better, he gets enough sleep, he might be fortunate enough to avoid ever having to take medications. This is a big opportunity for Jay. So if you're thinking about developing an app for Jay, you want to answer a variety of questions. And I list 3 types of questions that you might want to answer. So when is it most useful for that app on Jay's phone to reach out, interrupt Jay as he goes about his life, and send physical activity suggestions that might be useful for Jay at that moment? Should the type of suggestion differ depending on where Jay is? For example, if Jay's at home, should the type of suggestion differ? Which type of suggestion would be most effective in that setting versus if Jay is out and about, out in town, or already even walking, for example? And do the answers to these questions change as Jay goes through and experiences the intervention and becomes more familiar with these types of questions, or as Jay's hypertension gets better or gets worse? Should the answers to these questions change? These are the types of questions we need to address to personalize this app, an app, to an individual. And addressing these questions is really a problem. It involves many, many individuals, but one subset of individuals are data scientists, and that's where my lab come in. I come in. So I'm going to talk to you about a study called Heart Steps. This is a study for individuals who have early stage high blood pressure, early stage hypertension. And it involves 3 trials, 3 types of clinical trials. And it illustrates, at least from a data science perspective, how evidence accumulates across time, across different trials. So in the very first Heart Steps, it was only a 6-week study. Each individual wore a wristband, a tracker that tracked their step count, how well they slept at night. And we also had an app on their phone. This app had access to a variety of sensors, like we knew the location. When I say we know the location, I mean we know if they're at home. We don't know where their home is, but we know that they're at their own home, their own office, or maybe they're out and about in town. We know how busy their calendar is. We won't know what they're planning to do, but we know that their calendar might be blocked out, for example. Current location, how much they're using the app, whether or not they're tracking their behavior on the physical activity app. And we also, in this first version, we collected some self-report. So again, this question arises: in which setting should this health app deliver an activity suggestion that would be most effective for each and every individual? Another question we wanted to answer, and normally this is the case in these kinds of studies, that you have multiple questions you're trying to address. And another question was, how can you assist that person in planning their physical activity tomorrow so that they're more likely to be able to act on that and follow through with it? Very classic that you have multiple questions that you want to address. So what is a micro-randomized trial? So these are trials, these are not the kinds of trials that you and I are familiar with that are used in the regulatory setting in the States. In the regulatory setting, many of the trials are 2-arm trials in which the goal is to evaluate and confirm that the new medication or new device is better than what's currently available. That's not what these kinds of trials are about. These kinds of trials are about collecting data so that we can build a better device, So it's all about constructing a health intervention. So in this type of trial, each individual is randomized many, many times. And so in the case of Heart Steps, it's over 6 weeks. And as we're going to see, each individual is randomized 210 times. So every trial is different. It just depends on the duration of the trial. This is what I mean by micro-randomization, mini randomizations for each individual. So as I alluded to, 42-day trial, 5 times per day. These times are individual specific times. They're related to how if you were in the trial, it'd be how you organize your life, your usual time when you wake up, when you eat, and so on. They're approximately 2 to 2.5 hours apart. So you see the terms form morning, midday, and so on. And in each time, the phone, your smartphone would light up, it would audibly ping, and you'd see a suggestion on that phone for what you might do at that moment. And now, it wouldn't always do this, not at every one of the 5 times, it'd be 60% of the time, so around 3 out of the 5 times that would happen. The other type of planning that was to help someone plan their physical activity tomorrow was around every other day, and that would occur in the evening. So here you see little screenshots of how the screen of the app looked. On the right-hand side, it's these physical activity suggestions. We're going to look at the content of these suggestions. The content of these suggestions is tailored to sensor data on the individual at that time. And then on the left-hand side is the type of intervention that might be provided in order to help you plan tomorrow's physical activity. We're going to focus on the activity suggestions here. But as I said, both types we were trying to learn how to deliver both types of support. So to recap, we have this app can deliver a contextually tailored activity suggestion. At the bottom on the right-hand side, you see an example. I actually got this suggestion. It was in the winter, and it was in the morning on a work day. You can see the way the text is. It's, hey, look outside, not so bad, right? Maybe you could walk to work today or just park a bit further away. It was a very cold morning, I want you to know. So you can see it's trying to help me reframe how I'm thinking about this. It was a work day. I wouldn't have gotten this on a weekend, for example. And I hadn't gotten to work yet, so it knew my location was at home. Okay. And around 3 times a day, as I mentioned earlier, around 3 times a day, you'd get a contextually tailored activity suggestion. And again, the content of the message is always tailored to information on you at that time. So what is the goal of these activity suggestions? Usually, if you've ever downloaded an app, a mobile app, and I'm sure you have, you'll know this. There's many different components to the mobile app. And that's the case here. In Heart Steps, there were, even in this early stage, there were 6 components. So there's many different things. So one component was helping you track your behavior. So many components. So all of these other components are intended to help you achieve this this first bullet point. It helps you build up a set of ideas for how you might be more active in the life that you lead. But over the longer term, combined, say, with regular physician visits and other types of efforts in terms of helping you with your diet and so on, the idea is that this will all come together and help that individual reduce the chance of them having some adverse cardiac event, such as a heart attack. So this is only part of a whole set of support that would be provided to an individual. So we ran that first study, that 6-week study. Everybody in that study got randomized 210 times, every single person. What did we learn? So what you learn in each study informs how you move to the next trial, So that's what we're talking about now. So It was amazing. This study, it turned out these contextually tailored activity suggestions were highly effective. Individuals, these were sedentary individuals in the first HeartStep study. They got around 250 steps within a 30-minute period. Early in the study, if they got an activity suggestion relative to if they didn't get an activity suggestion, it doubled the amount of steps they would get. So it was strikingly persuasive that these activity suggestions were really worthwhile. Another thing we learned is there were two types of activity suggestions. One asked a lot of you, go for a 3 to 5 minute walk. The other type of activity suggestion that everybody liked was just to stand up, roll your shoulders, roll your neck, made you feel good. No evidence of any impact of that suggestion. Only the more burdensome suggestion the data showed any evidence of an impact. It's very interesting. This is not uncommon, okay? Sad, but not uncommon. But early in the study, we got this approximate doubling of people's behavior if they got a suggestion versus if they didn't. But around 3 weeks in, almost nothing there. This is also very common in the digital intervention space. And there was some indication that the effect varied by whether or not you were in a structured setting versus an unstructured setting. So how did this all affect how we went to the next study from a data science perspective? Again, I just want to emphasize, data science is only maybe 10% or 15% of the amount of work that's involved in creating a high-quality digital health intervention. But I'm speaking to you from that viewpoint. So how did it affect us? Well, we produced a better interface for the individual that might be more engaging so that maybe people could continue being responsive a little bit longer. We focused on these higher burden suggestions because they were the ones for which we had evidence that they might actually help people. And we developed an AI algorithm. And the purpose of this AI algorithm was to track an individual. And if they started to decrease in terms of their responsivity, to then back off and not bother them so much. And then track them, and when there's every now and then probe to see if now they're responsive again. And if they are responsive, then provide suggestions as appropriate. So we instituted and started an algorithm there, and that's what I'm going to talk with you about for the rest of this today. So this is V2 and V3. These are much longer studies, 3-month and 9-month studies, all with individuals who had just been diagnosed with excessive blood pressure, i.e. stage 1 hypertension. I'm going to call this personalized, and I'll explain why I use that word on the subsequent slides. So we just discussed a microrandomized trial, HeartStep's V1. That was one where every individual in the study was randomized 210 times, 5 times a day over 42 days. And they were randomized so that on average they'd get 3 messages, 2 to 3 messages a day. These types of trials, one can view these as sequential experimentation trials, because you're sequentially experimenting, trying to learn from that individual whether or not it's worthwhile in a particular setting to send one of these contextually tailored activity suggestions. So one way to personalize is to use a reinforcement learning algorithm. And this word reinforcement learning, the phrase reinforcement learning, it's also used in psychology, and it has a very different meaning in that field. So if you're coming out of psychology, it has to do with reinforcements that I as a human might receive that affect my behavior. When I talk about reinforcement here, we're talking about an artificial agent, i.e. software that's running the app and it's the reinforcements that this software gets in order to do a better job personalizing to the individual. So that's the type of reinforcement learning algorithm we're going to discuss. And the idea is the reinforcement learning conducts sequential experimentation, essentially probing whether or not each individual might be more responsive in a particular setting to getting one of these suggestions versus not. That's essentially what's going on. And as it accumulates information as it continually probes to see if people are more responsive in that setting, each individual. So what does personalization mean? How are we operationalizing that term? So if an individual's data indicates that as their data accrues on their individual, that in a particular setting, say at home, on weekends, in the morning, that's a particular setting, that this individual is more likely to be responsive, I walk more if they get a suggestion versus if they don't, then what the algorithm will do is it will be more likely to provide a suggestion in that setting. That's what we mean by personalization. And if a person is less responsive in that particular setting, then the algorithm is less likely to bother the person, is less likely to interrupt them. It will always probe every now and then, because people are not static. People change with time. So the algorithm has to be ready to learn that somehow things have changed in your life and now you might be more responsive, or now you might be less responsive in a particular setting. So there's always some probing going on. And we ran this reinforcement learning. We ran actually multiple algorithms in V2 and V3, but I'm going to talk to you about the reinforcement learning algorithm today. And so the goal of this algorithm is to do this personalization. When should an activity suggestion be sent? When should, perhaps even more importantly, when should we not bother that individual? Again, we're talking about at any of these 5 times per day, they're user-specific times, individual-specific times, that a suggestion might appear on their lock screen and provide a 3 to 5 minute tip for what the person might do to be more physically active. And the goal of the algorithm, the reward that's provided to the algorithm, is whether or not the individual actually responds to the message. How physically active are they subsequent to that time point? Each of those 5 time points, some of which they get a suggestion, some of which they don't. So a big challenge in this field is that activity suggestions, they're highly unlikely. I mean, it's highly unlikely that if I send you an activity, if the app sends you an activity suggestion, that you're going to be less active than you would if the app didn't send anything to you at all. So usually, the sending of a suggestion either has no impact on you or a positive impact. The potential negative impact of these types of suggestions are due to the fact that people, when they get repeated stimuli as they go about their life, they stop noticing the stimuli. And all of us have been in this setting. I don't know about you, but we moved to a house that was close to a railroad. And the first week we lived in this house, in the middle of the night, I'd wake up every time the train came by. But within 3 or 4 days, I never heard that train again. I habituated to the train. And this happens to all of us all the time. So when we get repeated stimuli, we habituate to it, and we don't perceive it. So the algorithm has to avoid the potential that the individual will habituate to the messages and they're just not relevant. Or worse still, the messages are aggravating. They interrupt you and it causes burden. So these are all delayed negative intervention effects. Of course, we want positive intervention effects. We want you to build a repertoire of ideas about how you can be more physically active. But the big signal in this type of setting is habituation and burden. We have to avoid that. Any kind of AI algorithm has to really pay attention to that. And I already kind of hinted at this when I said this algorithm should back off whenever there's signs that the individual is less responsive in a setting. It should back off, leave them alone. Okay, so what are these algorithms? So it turns out, at first it seems like, it has the word artificial intelligence, so you're thinking, man, it's got to be pretty sophisticated. It's got to be unintelligible because it says artificial intelligence. But it turns out these algorithms are very simple, conceptually at a high level. They're extremely simple. They have two elements. The first element is some sort of data analysis method that's forming predictions of whether or not the individual is likely to be, how responsive they're likely to be if you send a suggestion, a contextually tailored activity suggestion, versus if you don't. That's all this algorithm is doing. It's making predictions, forecasting, are you likely, in the setting you're in now, are you likely to be more responsive versus less? That's the first algorithm. This is called a learning algorithm. And in our setting, we use a methodology called Bayesian methodology. And this Bayesian methodology is an approach for updating your information, your understanding of a problem as new data accrues. So it's a very natural way of updating one's understanding of a problem as data accrues. That's the learning algorithm. All it's doing is forming these predictions about whether or not the individual is more likely or less likely to be responsive to a contextually tailored activity suggestion. The second element is the personalization strategy. This is a strategy for acting on that prediction. So how does that happen in this setting? So in this setting, because we're using this Bayesian methodology, which allows us to update our prediction as data accrues, this prediction is updated with a probability. It gives us a chance that the individual is likely to be more responsive in their current setting versus to a message versus not responsive. And these are called Bayesian posterior probabilities. So the data accrues, and now it's posterior to acquiring that data. It provides a probability, and this probability is the algorithm's best guess at what's the chance that the person is likely to be responsive. And the algorithms we develop have to include a term which is this delayed effect. That's that second term here on the slide. And that's the algorithm's it's anticipation of maybe we're going to cause habituation and people won't see the message, or maybe the algorithm's causing burden. So it takes the probability that the current intervention effect, that is the effect of sending a suggestion on you versus not, on your current physical activity, plus some projection of delayed effects, aggravation, the fact that might be less responsive in future because of burden. And it asks, what's the probability this is greater than 0? If that probability is high, the data evidence is indicating you're likely to be more responsive in your current suggestion. If that probability is low, the data evidence, the accruing data is indicating you're less likely to be responsive to a suggestion in your current setting. We take that probability, and that's the probability that is used to randomize whether or not the person gets the suggestion in that setting. That's the personalization strategy. Okay, I'm going to now show you some results from particular individuals in these studies. This was very exciting. We have a number of individuals like this. So I'll tell you a little bit about V2 and V3. They went on in Seattle at Kaiser Permanente, and many of the individuals started the study prior to the beginning of the pandemic and ended the study in the midst of the pandemic. And the data I'm showing you right on this slide is from one such individual. So this individual, again, it's in Seattle. The person just got diagnosed with stage 1 hypertension around November 2019, mid-November. And the person stays in the study to early August 2020. Seattle shut down due to the pandemic in late March, around this period right here. And you can kind of see the graph looks different, even though it's not clear what the graph's about. The graph looks different in this period above the March time period when Seattle is shutting down. Okay, so what's the graph about? Each dot is an output of that first element of the reinforcement learning algorithm. It's prediction of whether or not the person in their current state at that time, on that day, is likely to be responsive to a message versus not. So if the dot is above 0, that means the algorithm is predicting that the person's going to be responsive. It's good setting at that moment in time of that individual to send a suggestion. If the dot is below 0, it's saying, oh, there's not a lot of evidence here, probably, maybe not a good idea. Okay, and what we did, so that corresponds to the height of each dot. And you see there's a bunch of dots below 0, there's a bunch of dots above 0, so different times, different settings in this person's life, right? And what we did was we color-coded one of the settings, and this is called engagement. So there were 2 levels of engagement in this algorithm. Engagement here means that the individual was they were tracking their physical activity on the app. All by themselves, they were looking at the app, checking out, seeing whether or not, how well they were doing. And if they had been tracking it more often than usual, it's a blue dot. And if they were tracking their behavior less often than usual, there's a red dot. Okay. So, and again, these are just predictions by the algorithm, right? This is not the person's actual behavior. This is a prediction by the algorithm about the person's behavior. Okay, so what we see here is that very early on, the algorithm starts predicting that if the person had really been tracking their behavior, i.e. engaged, they were probably going to be more responsive to a suggestion versus not getting a suggestion. And it's just what we were extremely excited when we saw these types of slides. I mean, these figures, because what it's indicating to us is that the data keeps accruing. No matter what, it's pointing in the direction that if the person is currently engaged, they're more likely to be responsive to getting a suggestion. That's what we're seeing. Okay, so how does this translate into the personalization? Here's the probabilities with which the individual was delivered a suggestion, a contextually tailored activity suggestion. So you see those probabilities at the engaged times, the probabilities are much higher because it's mimicking the predictions made by the first element of the algorithm. And at the less engaged times, the probabilities are much lower. So all I did was I took these 2 slides and I put them one on top of the other. And this is what we mean by personalization. Personalization, what we mean is that the algorithm is predicting in whether or not the individual, this particular individual, this is going on in real time. It's predicting whether or not the individual is more likely to be responsive. It sees predictions that the blue top person is currently looking at their app to track their behavior, and it provides a suggestion with higher probability. And at the red times, it provides a suggestion with lower probability. This is what we mean when we say personalization. Okay. So here's another one I'll just briefly go through. Here's another individual. This was quite surprising to us. We had a number of conjectures I, in particular, I'm not even a behavioral scientist, and I had conjectures. I thought that if at a particular time, that person, at that time, in that setting, that person exhibited a lot of variability in their physical activity, I thought, well, they're more likely to be responsive to suggestions. Because a lot of variability in that person's physical activity around that time means they might have room in their life to be responsive. Well, okay, so here's one person, another person, a second individual, and here we're looking at two. Again, this person, entered actually in mid-September, and they left in around early August of 2020. And here the dots are coded in different ways. The blue dots are when the person has been tracking their behavior, they're more engaged. The red dots less. But the dots that have a black circle around them, this is when that person has been exhibiting in the prior days a lot more variability around that time when they have a black circle. And when they don't have a black circle, that's when they haven't been exhibiting a lot of variability. This was terrible for me because it was totally against my conjecture, because what we see is almost all the black circles, the algorithm is predicting, oh, the person is probably not going to be responsive in that setting. So if there's a lot of variability, this person, their data kept indicating repeatedly the person is less likely to be responsive. It was very interesting. Okay. And the probabilities attract all of this because the personalization strategy is tracking how the learning algorithm, the predictions by the learning algorithm. So I hinted at this at the beginning of this talk. How do we know, or is there evidence that the algorithm actually is personalizing? And I want to give you an example. It's taken from a different area, but it indicates that there's a lot of potential for misinterpretation in these settings. So suppose I'm generating numbers, digits between 0 and 9. There's 10 digits between 0 and 9, and I generate these digits each with probability 1/10. And I continually do this repeatedly. So you get this sequence of digits in front of you, like 0, 5, 3, 2, 5, 1, just this long sequence. And you look at that sequence and you see, lo and behold, there's a whole series, a run of 5s. You see a whole bunch of 5s in a row. Is this indicative that somehow I'm generating these numbers differently from each one having equal probability of occurring? Unfortunately, no. You'll get series of 5s just by chance. In other words, when you're stochastically generating digits, in our case, stochastically deciding whether or not to send a suggestion, you can get series of, in the case of digits, of 5s spuriously. It has no meaning. It's just chance. Well, here, is this happening as well? Could it be that it's just by chance that the blue dots are higher than the red dots? I mean, how do we know that the algorithm is picking up something significant about this person's behavior so that it really means that we should be sending this suggestion when the person has been tracking their behavior, their physical activity? That's the question. How do we address this? And so what we do, one thing we've been working on is how do we think about this problem? And here's a first effort. Okay, so what we're doing is we're just looking at the influence of engagement. Remember, engagement means the person has been engaged in tracking their behavior. The influence of engagement on the effect of the activity suggestion for this individual. The blue curve is the actual data from that individual. Okay, so the blue curve's real. It's not simulated. It's that individual's, it's how the algorithm is tracking that individual's behavior over time. And we see, again, on the horizontal axis, that's the day this individual is in the study, just like before. And the vertical axis is this estimate of the influence of engagement on that person's responsivity to getting a suggestion. And we see that it's getting above 0, indicating that it looks like that there's some positive effect. If they're currently engaged in tracking their behavior, it's worthwhile to send a suggestion. So that's why you're getting this blue curve above 0. Okay, so what's all those black curves? The black curves are recreations or simulations of that same individual, but under the ground truth that engagement makes no impact at all. None. Okay? So there's 2,000 black curves. Each one is a simulated version of this individual. It uses that individual's data, but it's under the ground truth that engagement is really not relevant. It's completely not relevant. So what do we see? Well, we see early in the study that the blue curve, that true curve, the projections made by the algorithm, it's well within the mass of all the black curves that just occur, but there's no real impact of engagement. This is amazing to me because I looked at this, naively, and I thought, whoa, man, only within the month of December, I'm already learning. My algorithm's learning something. I'm really proud of myself. This is really good for grant funding and so on. But no, that's bogus. That's completely bogus. That's stochasticity. It's only as time goes on that the blue curve starts to drift above all those black curves, and you're really seeing strong, signal. Engagement, yes, if the person's engaged, it's worthwhile to send that suggestion. So it's back in here. Yeah, the algorithm's learning something, appears to be learning something. So it's very interesting. So in this way, we can provide that truth in advertising to our collaborators. It's not just that AI is cool, it's that AI, when is it helping us? So I want to give you this slide before. And this idea of experimentation, or probing to learn. This is an idea that's pervasive in our modern society. In fact, let me just go to this first bullet point. It's been known R.A. Fisher is one of the fathers of statistical genetics. He's also one of the fathers of the statistical field and experimental design. And he has this whole notion of this iterative nature of experimentation. And what you've seen today is we talked about, I had 3 studies, the iterative nature of experimentation between studies in order to learn. But within a study, there's the iterative nature of experimentation within a person, trying to learn what's better for that person when to send an activity suggestion. In our world today, almost all of the experimentation that's going on is in the tech field, and it's to sell us things. I have 2 quotes, one from Google, the other from Google, scientists at Google, as well as scientists at Facebook, and how they're constantly using experimentation on us to learn how to keep us on the page, to get us to click on ads, and so on. So what we really want to do is use this continual experimentation, continual probing, to help improve digital health for individuals. Our long-term goal is that when you think of a digital intervention or Siri in your home, I'm mainly interested in people who are struggling with a chronic disorder, is that the reinforcement learning algorithm, the RL algorithm, is just one of multiple intervention components. Some of the components are helping the person plan their behavior, helping them figure out how to eat better, helping them how to manage their stress better, or be more physically active. And then there's also an algorithm that's constantly trying to tailor these messages to the individual, relearning, learning and relearning. So this brings to mind this wonderful song by Cole Porter, And here, we're going to hear it by Tony Bennett. This is so close to my heart, it's unreal. Let me see if it... Yeah. Experiment.
Make it your motto day and night.
Experiment.
And it will lead
to the light.
To the light. The apple on the top of the tree is never too high to achieve. So take an example from Eve.
Experiment.
Be
curious. That's what experimentation's about.
Interfering friends may frown. Get furious at each attempt to hold you down. If this advice you only imply, the future can offer you infinite joy and merriment. Experiment.
Thank you. Okay.
Wow, fascinating talk.
Yeah.
Absolutely fascinating. Okay, we have a few questions. Feel free to ask more. We have a little bit of time. Fatigue. Since fatigue is a common problem with long-term digital intervention, should we be using them, to build healthy context-dependent behaviors? I think should be using algorithm to build healthy context-dependent behaviors.
Yeah, so that's why they're contextually tailored activity suggestions, right? They're supposed to be meaningful to you at that moment, right? Useful for wherever you are. Like if the weather's bad, you don't want to, well, depending on the person, you're probably not going to suggest going out for a walk. It just depends on the person. Some people may not mind that if it's raining to go for a walk. But fatigue, this is the problem, right? When you have a chronic disorder. It never ends. There's no magic blue pill. You're going to struggle with it. You know, addiction is like this, mental illness. A lot of types of mental illness are like this. Smoking, if you're trying to quit, it's a big problem. You're trying to manage your weight. It's just chronic. It just never goes. And so you can imagine that a good way for these algorithms to work is they come in, and when you're able to manage or act on these suggestions or ideas or tips or connections they might offer, they make those, but then they back off, and all you do is you have this very low-level monitoring. In fact, people will do better for some period of time, so why even induce fatigue if they're doing well right now? So it's a lot of the algorithm is like, when should I just passively monitor and not bother the person? And when should I come back and try and provide some sort of support? That's the ideal. That's what we want. We want that, yeah.
The next question is actually a follow-up to that, and it's quite interesting. So determining the negative impacts of a suggestion will depend on the breadth of what we measure.
Yes.
So how much data should we be collecting, in your opinion?
Well, okay, so there's a vast amount of data that's being collected, as you can well imagine, because there's sensors on your phone, there's sensors on the tracker. So between these studies, a whole variety of data analyses are conducted to try and understand maybe there's specific settings that we didn't pay attention to in our AI algorithm in the first round that we should have paid attention to in the second round. So there's this iterative learning really is going on between those studies. And the large amounts of data tends to contribute more to the iterative learning that goes on between studies. Because then you pool information across individuals and you try and understand, are there some common themes across individuals? Within a study, it's really much more about each person. And the algorithms have they have a warm start, an initialization. And they're usually initialized by what we learn by pooling across people. But then they become more and more personalized as they operate on each individual separately. There is, of course, ethical issues, privacy issues. It's really important in this field because we are running real clinical trials. These are trials that are registered trials. They're all protocolized ahead of time. It's a highly constrained environment. You have to monitor for adverse events. I mean, it's just not willy-nilly. For example, with location, we don't store one's GPS trace. We look to see, are you at home, work, or maybe near a place where you normally are physically active. But I don't have to know, if you're in the study and I'm in the study, we don't have to know where your home is and my home is. We might want to know attributes of the environment of where your home is. Say, are there parks near you? But I don't have to know the exact address of your home. And so there's a lot of efforts to characterize the data before it's stored on some external server. You have to be really careful. It's very complicated in this setting. Like, I was part of a study where these were individuals, a lot of individuals, many of whom were homeless. This was, they were in recovery they had been addicted to opioids. And there, it wasn't about privacy in the sense of don't send data to the cloud because we're worried that somehow someone's going to access the cloud. No, that was not the problem here. Here, the problem was get that data off that phone ASAP, because if they're caught performing an illegal activity by the police, they might be able to access the data on the phone and thus incriminate the individual. So privacy is complicated in this setting. It's not so simple as, oh, let's just not put data on the cloud. It's just not that simple. Right. Yeah.
What forms of aggravation or potential harm did the trial discover? What social categories of conditions are most suited to benefit with most minimum harm?
Yeah, so harm here, in this particular study, it was about tips for physical activity or ideas for how you can plan your activity tomorrow, tracking your behavior. The biggest harm, I think, is it interrupts you as you go about your daily life. It might take you away from some other more meaningful behavior, right? That may not be considered harmful, but I consider that potentially harmful. And so that's the reason why you have this mantra of don't intervene if it's not going to really help. Don't have that. That's why that mantra is pervasive. So there are studies that we really have to be worried about more what could be perceived as greater harm. Like for right now we're getting involved in, I'm very excited, we're starting to get in studies where the individual has a social network. In particular, one of the first studies is these are kids, they had a terrible cancer and they had to have a type of stem cell transplant. And after the transplant, they have to be adherent. These are adolescents. They have to be adherent to these awful medications for 3 months. They are adolescents. They don't want, they want to have a life too, just like everybody else. And so their social support is their family. And so we'll be providing messages or suggestions to both family members and the child. And there, we really don't want to somehow cause increase a poor relationship, or we want to increase the supportive nature of that family structure. So we have to really be careful about monitoring, figuring out how to monitor the supportive nature between, say, the primary caregiver and that child. So that you have to be really careful about that because these are families under a good bit of duress. Yeah.
Let's go back for a moment to habituation.
Uh-huh.
And how do Facebook and Google deal with the habituation issue?
Oh, I think they're starting to deal with it, but the quotes I took from you before, it wasn't relevant because every time point at which a randomization occurs was with a new user, a new customer. So who cares if you have a bad experience? They're not going to see, you're gone, right? You don't care. So the sequential decision making is more on the population level as opposed to within an individual. Now, longer term, there is customer retention, but I think they're just starting to go down the path of customer retention. And now you do have to pay attention. They may want a positive type of habituation. I love listening to YouTube, so I'm going to watch it as long as possible. But you don't want a negative habituation in the sense that I no longer see the notifications from YouTube that remind me to go back to YouTube and watch it as long as possible. Mm-hmm. It just depends, it's not, I don't want to imply that these companies are evil because I love YouTube, so I don't want to imply that. It's just that there's a different utility function when there's a commercial product as opposed to a health-related product. Just different things you're trying to optimize. Yeah,
I'm just wondering how much of a problem that is for company. I'm just wondering how much of a problem that is for
I think there are addictions now starting to happen.
I'm thinking about habituation.
Oh, habituation, then it's not a problem. Habituation in the sense that I start to ignore your notifications.
Right.
That's okay for the person. It's just not so good for the company.
Exactly. Yeah.
Habituation in another sense, I formed the habit of watching YouTube every single morning for longer and longer periods of time. That's not so good for the customer.
Right.
But it might be good for the company. So it's a different,
Yeah. So let's see, we may have time for one more question. Do the privacy requirements of your clinical trials put you at a disadvantage against tech corporations working on the same issues?
Yeah. Big time. That's my opinion. We strive in the academic field, in the medical field, to be really very, we really try hard to respect we try. We may not do it, but we try to be respectful of people, of their data, and sometimes we don't balance the advantages of trying to help people. There's really pros and cons to a lot of this. And sometimes we aim for the gold and we don't try and just get a little bit better. And that's where the trade-off comes. We aim for the goal, we want perfect privacy, we want to respect everybody perfectly, and so we just don't do anything. That's going for the gold at the expense of making progress. And so trying to find that balance of making progress but not doing very much harm is really non-trivial. It's a non-trivial task. Yeah.
Thank you, Susan, for your presentation, for your thoughtfulness. I want to thank the audience here in the room with me and online. Thank you for your questions. Please check our website at radcliffe.harvard.edu for future events, and you can also watch past events there. Thank you for joining us today, and have a great rest of the day.
Thank you.